So good morning dear students. In the previous session we have learned about different types of relation, that is reflexive relation, especially reflexive relation, symmetric relation, and one is transitive relation. Let us take two examples to learn that three types of relation in more concrete way. Okay, I have taken two examples. Let us see the first example here. So the first example here, the set is A, 1, 2, 3 are the element, and the relation is given in the roster form. It is written. Okay, this is the relation you are given. So now you are asked whether this relation is reflexive or not. Reflexive relation or not. Reflexive relation, the definition is a relation is said to be reflexively A is related to A for all A belongs to A. If for every element, if A is related to A, every element is related to itself, then we say that it is a reflective relation. For now, element 1, it is related to itself or not? Yes, it is. 1 is related to 1. Now let us consider okay, this is clear. 2 is related to 2 or not? 2 is related to 2 or not? Let us see here. Every element I am testing here. Okay, here it is. 2 is related to 2. So this is also clear. Now the third case is 3 must be related to 3. Is there any element 3 here? No, it is not there. So since we will say, so it is not reflexive relation. Why it is not a reflexive relation? Because 3 doesn't belongs to R. Or we can write the same thing, same statement, we can write in this way. This is not reflexive because 3 is not related to 3. Okay, understood? Okay, now secondly it is symmetric or not. Symmetric means, what is symmetric? If A is related to B, A is related to B must imply B related to A. Now, if A is related to B, then we must have B is related to A. Now see here, 1 is related to 1. So 1, 1, 2, 2, we need not think more about all those elements, because 1 is related to 1 means again this one will also be related to this one. So these two we are not going to consider. Let us consider this one. 1, 2. 1 is related to 2. Whether now we will see whether 2 is related to 1 or not. 1 is related to 2. 2 is, yes. These two, see, you check these two. 1 is related to 2 and 2 is related to 1. One by one we will have to check all the elements. Okay? Leaving these two. Again, so this is clear. 2, 3. 2, 3 is there. So we must have 3, 2. 3, 2 is there. So this is also clear. Again, 3, 2 is there. We must have 2, 3. It is there. Again, 2, 1. So we must have 1, 2. 1, 2 is there. So this is a symmetric relation. That we'll have to write logically. How will I write it logically? So we'll write in this way. This is symmetric because A is related to B, implies B is related to A. For every AB belongs to A. Means for all element wherever we have got 1 to AB, we have got BA also. That is the meaning of this one. Okay. Now let us think about transitivity. Transitive relation, whether this relation is transitive or not. Transitive, the definition of transitive is if A is related to B and B is related to A, then we must have related to C, then we must have A is related to C. If AB is there, if BC is there, then we must have C. That means what? If AB is there, if BC is there, we must have what? We must have AC. We must have AC in that set. So if this is there, then we must have AC in this set. That means how we'll see the second element and the preceding element, first elements are same. In that case, omit these two, AC we must have. Okay, let us check here. Ending with 1, starting with 1, ending with B, starting with B, ending with 1, starting with 1. So omit these two. Again, what we will get? 1 will go, 1 2 will get. Whether 1 2 element is there or not, it itself is 1 2. So it is so ending with 1, this is clear. Ending with 1, is there, starting with 1, is there any other element? No. So this is clear. Now this ends with 2. Now we will see starting with 2. Element starting with 2. Starting with 2. Starting with 2. Here, so 2 2 you omit. 1 3 must be there. 1 3. Is it there? 1 3. 2 2 you cancel. 1 3. 1 3 is not there. So that means what? That means what? 1 is related to 2. 2 is related to 3. But 1 is not related to 3. 1 is not related to 3. So this is one example is enough. One example is then enough to show that it is not transitive. So this relation is not transitive. Hopefully you have understood. That means every element you have to check individually. Okay. So this relation is not reflexive. It is symmetric and it is not transitive. Now let us take this example. Here the elements of set A are 0, 1, 2, 3. See, the relation is given in this way. This is the relation. Okay. Now it is reflexive or not? We must have 0, 0, 1, 1, 2, 2, 3, 3 to be reflexive. 0, 0, 1, 1, 2, 2, 3, 3. So it is reflexive. Number 1. Number 2, transitive. Symmetric. Symmetric means if 0, 0, then the reverse of this element 0, 0 must be there. Reverse of 0, 0 is 0, 0. For these two will not see 0, 0, 1, 1, 2, 2, 3, 3 because their reverse is itself. Okay, these two elements, these 4 elements will not see for symmetric. Now check this one. 0, 1. Reverse is 1, 0. It is there or not? So this is clear. Again 0, 2. 3, 0 is there or not? 3, 0. It is there. So it is clear. 1, 0 is 0, 1. It's reverse. So it is clear. 1, 1. It will not see. This one will not see. 3, 0. Its reverse is 0, 3. So it is also clear. That means what? This is a symmetric relation. Now third is transitive. Transitive, you may find it hard in the beginning. Once you have practice, you can learn it, you can get it very easily. Transitive means what? We'll have to see the second element is 0. So starting with 0, we will have to say all the elements starting with 0. This one. So 0, 0. These two will go. Again, 0, what we are going to get? 0, 1. If these two cancel, 0, 1. So 0, 1 is there. So it is alright now. Now again, starting with 0, here also we are going to get. Starting with 0. Starting with 0. So these two you omit. 0, 3. We must have 0, 3 in the set. It is there. So this will also not disturb you. Again, no element is starting with 0. So this is alright. Now come with this one. Here in this case, ending with 1. So starting with 1 you say. Starting with 1. Here is 1. So cancel this to 0, 0. 0, 0. 0, 0 is there already. So alright. Again, starting with 1 you will find out this one. These two you cancel, what you are going to get? 0, 1, 0, 1, 0, 1 is an element here of R. So with 1 it is finished, so it will not disturb you. Now come here. So starting with ending with 3. So beginning with 3 you say. Beginning with 3. Beginning with 3 here no. This is beginning with 3. So if these two you cancel 0, 0 you are going to get. So 0, 0 is an element here. So it is alright now. So come here. 3, 3 will go.